Hello everyone. Today topic is on the integral power of the matrices. Now, if A is any matrix, then A square is equal to A into A. As we know by associative law, A square into A, that is equal to in bracket A into A, and that is equal to by associative law, that is equal to A in bracket A into A, that is equal to A into A square, that is equal to A cube. So we can write A square into A is equal to A into A square is equal to A cube. So we can write A into A up to n factor, that is equal to A raised to power n. And next है a raised to power m into a raised to power n. A raised to power m is equal to a into a up to m factor. A raised to power n is equal to a into a up to n factor. Combining these two, we get a into a up to m plus n factors, and that can be written as a raised to power m plus n. Similarly, a raised to power m raised to power n, that is equal to a raised to power mn. Now, if I is the identity matrix, or we can say unit matrix, so I square is equal to I cube and so on. I raised to power n, that is equal to identity matrix for all n belongs to natural numbers. Next come to example. If we are given the matrix A 2 minus 1 0 3 of the order 2, find out A square and A cube. Now A square is equal to A into A. By matrix multiplications, we get 2 1 0 3 into 2 minus 1 0 3, that is equal to 4 plus 0 minus 2 minus 3 0 plus 0 0 plus 9, and resultant matrix is equal to 4 minus 5 0 9. Now we want to find A cube. A cube can be written as A square into A, that is equal to 4 minus 5 0 9 into 2 minus 1 0 3. When we multiply these two matrices, so resultant matrix will be 8 minus 19 and 0 27. Next example is, if A is equal to 0 0 1 second row, 0 1 0 third row, 1 0 0, find out A square and hence A raised to power 6. First we calculate A square. A square is equal to A into A, that is equal to 0 0 1 0 1 0 1 0 0 into 0 0 1 0 1 0 1 0 0. When we multiply these two equations, then we get resultant matrix, that is equal to 1 0 0 0 1 0 and 0 0 1, that is equal to identity matrix. Next we calculate A raised to power 4. A raised to power 4 is equal to A square into A square, and we multiply these two matrix, then again we resulted matrix will be equal to 1 0 0 0 1 0 0 0 1, that is again identity matrix. And next come to A raised to power 6, that is equal to A raised to power 4 into A square. A raised to power 4 is equal to identity matrix. A square is again identity matrix. Now identity into identity again multiply, we get identity matrix. That implies A raised to power 6 is also identity matrix. Next come to next example. If A is equal to 1 0 0 0 1 0 0 0 1, then prove A square plus 2A is equal to 3i. Now since we are given A is equal to identity matrix, now A square is equal to A into A, that is equal to identity into identity, again we get identity matrix. Now A square plus 2A, substitute the values. A square is equal to I plus 2A into I plus 2I, that we get 3I. That's all. Next last example है, if A is equal to x1 1 0 such that A square is identity matrix, then find out the value of x. Now first we calculate A square. A square is equal to A into A, that is equal to x1 1 0 into x1 1 0. When we multiply these equations, resulted matrix is equal to x square plus 1 x x 1. Now we are given A square is equal to identity matrix. That means x square plus 1 x x1, that is equal to 1 0 0 1. Now by definition of equality of the matrices, their corresponding elements must be same. So that implies x square plus 1 goes to 0, x goes to 0, and we get x is equal to 0. That's all. Thank you.